This video is going to go over Chronbach alpha and path analysis, which are two of the things that we encountered in our second reading for this week. So, what is Chronbach alpha? So, when we're trying to make a measure, we want to make sure it works consistently, so that's reliability. But how do we actually prove this? So, when we're doing the statistics, to prove this, we use Chronbach alpha. So it'll usually have that alpha symbol to test for essentially if there is consistent response happening or a lack of consistent response, which tells us something is up and we need to deal with it. So how does Chronbach alpha work conceptually? I'm not going to go into the math on this, but we can understand how it's being used so we can interpret it. So Chronbach alpha is a way to compare a person's responses in a bunch of different ways, but we're looking at an individual's response. So we might compare a person's response within our measure if we want to see that they're rating items as we expect. So if we are creating a measure that measures one particular thing across different questions, we would expect them to be rating higher or lower based on whatever it is that they are rating. So say if we're developing a measure based on math self-efficacy, and that's all our questions are based around is different questions getting at that same construct, then we would expect a person who is high in math self-efficacy to be rating those items consistently high. If we were getting a bunch of varied results from that person, we're going to suspect that something is going on with our measure. Either we aren't measuring one singular construct, we're measuring multiple things, or we just have bad question design and the questions are either not readable or they're confusing to the participants, so they don't know how to answer. So we use an internal consistency test, which we'll use Chronbach alpha as kind of the output value to tell us, are people responding consistently based on how they are rating? So if they're rating consistently low, are they consistently low? Are they consistently high? Or are people all over the place? Now, we might also want to compare a person's response to a different form of our measure. So if you recall back to when we were talking about validity and reliability, the first video lecture that I ended up doing, we would see, you're going to see these words and think that they're familiar because they are. So we could be doing a test of alternate forms, so maybe a paper versus digital, maybe we have different kinds of questions that are similar but different enough to prevent cheating, whatever we're doing. We might have different forms of our same measure, and we want to make sure that regardless of the form that we give, it's accurately measuring the person for whatever we're trying to measure. Because if it's not, then it's not working like we want it to. We might also have them take the test again at a later time, and so that would be test-retest. So can it consistently give similar results for whatever construct we are measuring, presuming that there's no change in that construct. So just we test a person, we don't do anything, and we test them a couple weeks later. Are we getting similar, responses from that person, assuming nothing has happened? So when we see a Chronbach alpha being used, we will see a value between 0 and 1. And similar to how we've been interpreting other things, the closer to 1 we get, the more similar a person's responses are. So if we have high internal consistency, so we're getting 0.8, 0.9, that means a person is answering, consistently high or consistently low across the whole measure. So that value here doesn't necessarily mean that the person is answering high or low. It means that regardless of what level they're answering at, they are consistent across the whole measure. If we were doing alternate forms or test-retest, it would be looking at the similarities in did your responses match more or less what you gave the first time or across different forms of the measure. Now, it's usually never exactly 0 or 1 because Chronbach alpha has an error component included in the math that it does. So it is accounting for the chance that a person's responses can be influenced by a bunch of different things, just, the randomness of the universe, or that they are potentially guessing or random answering. So there is a little bit of a control, so it is a more conservative estimate of reliability than if we were just doing a direct like one-to-one comparison. Because there's a chance that if they were guessing before and they were guessing afterwards, they could guess the same answer. It depends on what we're measuring, how much of a concern that actually is. So for some things, it's not a concern. For others, that might be a larger concern, in which case you would want to use additional measures of reliability, probably validity too, to ensure that your measure is working the way you intend. And hopefully you're not getting a bunch of people who are just random guessing, because, I mean, if they're randomly guessing anyway, your measure might be reliable and valid, but they're randomly guessing. And so that isn't a factor of your measure. So it is a good thing to have a bunch of different ways for testing reliability and validity to account for that other side of it, the person side. So why do we need Chronbach alpha? Why do we need to be paying attention to it in papers? Because, well, if we're, in the context of this class, you're probably not going to be doing the research, but you're going to be consuming it. So we want to look at Chronbach alpha and know how it works, because it can help us know if we can trust the relationships that we see in the results. So if their measure isn't reliable, so it's got a low Chronbach alpha, which typically we would say anything under 0.6, we would be kind of concerned about. Once we get under 0.5, we're getting pretty unreliable. If we're in that range, we don't really know what the measure's actually capturing, because it's apparently variable, and who knows why it's being variable. So if the researchers are publishing something that has those values, we'd be kind of concerned about those results. Often nowadays, if somebody was going to be publishing, they have to A, report this information, and B, if their Chronbach alphas were concerningly low, it would be caught in peer review, where this paper would not get published because that is concerning, unless their goal is to prove that a used measure isn't reliable for some reason, in which case then that's information we want to get out to the public. But if they are just creating a measure and using it and then trying to make claims about whatever they're measuring, but their measure isn't reliable, you're not going to get through peer review. So you will see things that have low Chronbach alpha, and often that's because either those studies are really old, or those studies are trying to let you know where a measure should not be used. And this is usually looking at it in terms of a measure designed in one population being used in another population or another context, or a measure that was designed to measure something specific that somebody is using or testing to see if it's measuring other stuff as well. So there's a lot of different reasons people could be publishing things that have low Chronbach alphas. So you do want to read in detail why they're doing their study and what they're interpreting in terms of those low values. But in general, just for a standard, we're using a measure, we're reading something that has developed their own measure, or they've compiled across measures to make a composite, and so we want to know the reliability of the composite that they've made. We want to check these values because we want to see how reliable that measure is, so we know that the results that we're going to go read in the next section, how much we can trust those results. Now, we generally want to see values around at least 0.7 and above. Ideally, the close to 1, or as close to 0.99, because you're never going to get to 1. As close as we can get to those, the more reliable it is. And so what I wanted to do was grab the tables, or a part of one of the table that they gave us in the reading that gave us Chronbach alpha. So this table is in the methods, and it's talking about the different constructs that were in the questionnaire, because it was what I would consider a composite. It's measuring several different things. So in this sense, we're looking at one construct, which is the gameful experience construct that they gave. And there were sub-constructs under that, and we just see the one now that's accomplishment. But what I want to focus on is the 0.9 Chronbach alpha over here. So the 0.93 is for across the whole construct, in which case this was gameful experience. Within that, they had different sub things. So there were 8 questions or items that were in the category of accomplishment. So we want to look at both depending on what this table gives us, we want to see what's happening in these kind of subcategories. So the Chronbach alpha for the accomplishment subcomponent is 0.9. That means, you know, if people are rating these questions pretty high, generally they're rating all of the questions high. They're not rating them variably. Then we also want to see across the whole construct that we're looking at, because they have subcomponents, what is the Chronbach alpha across the whole component? And that's 0.93. That is really strong. I feel like I can trust this construct. Whatever they are measuring here, this gameful experience, it's getting measured really well, and consistently too. That is the key for Chronbach alpha. It is consistently measured um, across the construct. So when I'm looking at this table, and I'm essentially looking at this table to check how good their measure is working, I'm looking at these Chronbach alphas, and I don't want to see anything ideally below 0.8, but my personal threshold is if it's under 0.7, I'm wary of trusting it. Sometimes things will get published in like the 0.6s, but really, the better your measure's doing, it should be in the 0.8, 0.9 at minimum. So this looks great. It's a 0.9, 0.93. I think in this one, they had one that was in I think it was like 0.86 or something like that. Not bad. It tells me there is a little bit more variance going on. And so we do see this measure here of explained variance. They're looking at this across all of the different subconstructs, so I don't want to go into that. But that is looking at how much of a person's response is explained by how they were answering these particular questions. In this case, it's doing some work, but it's doing it at 0.8%, but there's a lot of other components that were in the whole questionnaire. So this is just a little component of it. But in general, for this lecture, we're focusing on what Chronbach alpha is telling us about the measure in terms of how consistently it is measuring people on these constructs. Now, the other thing that this paper had was a path analysis. So researchers may suspect that the constructs that they're measuring, especially if they're measuring a bunch of different constructs, have relationships to each other. Usually, that's the bare minimum, that they have relationships. Now, we can look at relationships in a variety of ways. We can look at them with correlations, which tells us if there is a relationship, but it doesn't tell us a direction. And we can look at them through regressions, where we can start to tell, do particular variables have impacts on other variables? And what we can also do is what is called a path analysis, when we suspect that there are particular chains of relationships occurring. And it uses the math that is going on in the regression and does a little bit, it essentially extrapolates from what's happening in the regression. So it's related to it, but not completely the same thing. But essentially, it's allowing us to test out if particular relationships are happening in the data or not. And we can see this in a table, but usually when there is a lot going on, they will visually represent this for us. And that's what this all right, so this is the figure that they published in that article. That is a lot going on, a lot of circles and rectangles and all sorts of numbers. So I'm going to start this by doing kind of an out to in interpretation, and then going from a left to right interpretation. So starting off, I want to just talk about what these symbols are. So these big circles are large either constructs or key variables that they wanted in the model. So if you recall back to the reading, they had 3 constructs that they were measuring in that questionnaire: the gameful experience, the motivation, and the collaboration. They also included 2 other variables that they wanted to see how they were impacting different variables. So they included students' grades and their gender as well. So big circles, big key variables that they're testing for in this path. The small boxes tell us what the subcomponents are doing in terms of more or less what components were most impactful in terms of the larger construct. So these small boxes on the left or right or left, not left, of these circles are the subcomponents of the big topic. So in that table that we were looking at before, we know that accomplishment was a subcomponent of gameful experience. So these boxes are telling us what the data source essentially is. So all of the different subcomponents, also whatever the student's sex was and their grade, are all going into these big circles. So that's kind of the out to in. Now I'm going to go left to right because you may have noticed there's arrows in a lot of places. All of these lines have arrows. So I'm going to start with the gameful experience because this is the variable they wanted to see if it had impacts on a lot of other things. So we can look at what gameful experience is connecting to. So it connects to motivation, it connects to gender, collaboration, and grade. So now that we see what it's connecting to, which is everything in the model, we want to actually see what these numbers are on the lines, because the numbers tell us essentially how strong the effect of this connection is. So we have 0.319, we've got 0.47, 0.039, and 0.717. So we have a kind of range of numbers where that's a fairly strong relationship right here. It can go past 1. When there's multiple things influencing something. So we, like you see over here, there's 0.106. So we can go past 1. So our scale is a little bit, there is magnitude to it, but it's not necessarily 0 to 1. So we have 0.7, 0.4, 0.3. So it's got less effect on grade and collaboration as it does on motivation. So if I'm to interpret this, I would say potentially, the more you feel like you're having kind of a game-like experience, the more you're motivated in this game with, depending on what kind of questions they ask to motivation. But there's some impact on the more it feels like a game, and it has qualities of game, the more I'm motivated to do things. Now, there's a little bit less of an impact on collaboration and on the grade, so there is some effect, but it's not necessarily a strong effect. So not everybody is experiencing the benefit of it being a very gameful experience on having an impact on their grade. So we do have some kind of big variables, and we have different connections here, so we can see there's a lot going in terms of what we're looking at gameful experience is impacting. We can also look at what is called indirect effects. So starting over here at gameful experience, we can go up to grade, and then we see that grade is connected to motivation down here, and it's also connected to collaboration. Now, unfortunately, it's not a very strong connection here, and in this case, it's actually a negative connection, so I would imagine that is, if you're worried about your grade or your grade is not very good, your motivation is going to be potentially lower based on that negative, because we're getting an indication of the kind of relationship happening. So there is a kind of indirect connection, but however, for gameful experience, that direct connection is the more important one. It's not really getting filtered through grade to affect collaboration, nor is it really getting filtered through grade to affect motivation. It's just directly affecting it. And so there are a couple indirect effects here. We also have one where we could look at the gameful experience's effect on collaboration as collaboration impacts gender, which it's not really in this case. And they also had one to see if gender was impacting motivation. But again, it's a small value, not indicating to me that there's a strong effect. So the purpose of this whole model is to tell us where relationships are happening in the data and in what direction. So the key here when we're looking at something like this is what are the big constructs, in which case they use circles for theirs. There's not a super standard way, so you would need to do a little, and you would need to read the article to know what gameful experience was supposed to mean and what these other words like challenge and playfulness are supposed to mean. I knew this because that table helped me really see, okay, gameful experience has these 3 subconstructs. So I knew that these were subcomponents to the gameful experience. So you do need the context of the article, and you also need to do a little bit of graphical interpretation in terms of, okay, I need to know what arrows are going to what, so I can interpret what relationship I'm supposed to be paying attention to, and then also doing some numerical analysis of how big or small is that number, and if there's a negative sign to indicate the kind of relationship going on, um, whether it's a positive impact or a negative impact. So there's a lot going on in here in terms of impacts. So it really is, it can be kind of complicated, and this is also ideally where the authors will explain these relationships as well in the writing that's in the results section. But I wanted to walk through this figure because you've probably never seen anything like it, and if you read other articles that have a path analysis or a similar kind of analysis that is called a factor analysis, they often use these visuals to represent how particular items are loading onto a construct or how constructs are influencing each other. So you'll probably encounter this again the more you read research. You can get through it though. It is possible.